And then that's tomorrow. Make sure we're all set. Yes. Yes. Okay. Hopefully that's working out. All right. So the calendar isn't much good to you other than to say it is, there's some links to Perseverance, except for they're not live links. They're live on my PowerPoint. So just a reminder, there's a quiz tomorrow. Also, I'm going to go over this polyatomics with multiple hydrogens thing. And then we've got some practice to do. Your homework will be to do some practice on the sciencegeek.net site that we used with the flashcards last week. I put a whole string of links to videos. We're going to watch part of a video, probably. Excuse me, because it's really interesting and he gives us some background information. The actual website that I was watching on with physics is not on here, so I will have to add this to your list. But at any rate, big day. We should, it should enter the Martian atmosphere at 12:48, so that'll actually be during sixth period. And then we don't know if it's going to make it. It takes almost 12 minutes for the signal to get back to Earth. So we won't know until just before 1 o'clock if it managed to land safely. It's quite a complicated endeavor, as you might remember, or from past ones. So let's go through the review and the information, and then hopefully we'll have some time to watch the live feed. I want to show you a couple things in your classwork. Boy, my internet is really very good today. What's going on? It's taking forever to load. So I put an article and questions from a magazine that I get called Chem Matters into your classwork. I was going to make that an assignment, and I decided not to make it an assignment. Gosh. But it can be extra credit if you're interested. It's not required. You don't need to submit it if you don't put anything down. Like I said, I thought I was going to do it for an assignment, but it's a little bit much right now, and we have a quiz tomorrow, so well, it's just, if you want to do it and read the article and do the questions, email your answers to me, and I'll give you extra credit. How's that? What I do want to, we are going to work on is these practice quizzes, and this is due tomorrow. There's 20 questions on each of these. So these are live links on the doc for you to get into these practice quizzes. I better open them up right now. Okay, so we'll come back to those. I want to share one thing with you first, and this has to do with polyatomics. We got this big long list of polyatomic ions weeks ago now, but in that last column, there's a whole bunch of them with hydrogens at the front. And I want to point out to you that they aren't acids, they're ions because they have charges as a superscript. And I'm also going to, physics. I've got a lot of tabs open. Maybe that's what's causing everything go so slow. I also want to show you how we get some of these ions. It's super easy. Once you know the Nick, the camel, Ada, clan for supper, and phoenix, once you know those 8s, you will be able to figure out the ites, which we already talked about, but you'll also be able to get some more by sticking a hydrogen on the front of them, and I'll show you what I mean by that. Whenever this stupid thing opens. Am I sounding all glitchy to you guys?
No, you sound perfectly fine.
Oh, good. Thank you so much. Why this is being so difficult on my end. There we go. All right. So, this isn't the smoothest writing, but it was the easiest to do earlier. So I'm going to start with a simple polyatomic ion that I hope you know. CO3, right? And that's got a 2 minus charge. So if you remember our little silly sentence, C for carbon, 1, 2, 3 vowels. I think I'm another English reader. 3 consonants makes 3 oxygens, 2 vowels, so minus 2 charge. So Nick the camel, A the clam for supper, and phoenix, right? So hopefully you guys know this is carbonate. And it's a very, I guess I ran off the page, it's a very important polyatomic. It doesn't catch the edge. All right, so I'll put it down here. There. Show up. Yep. All right. So the carbonate ion. And if you notice, the charge is a minus 2. So that's great. The thing that you probably noticed is there is, let's see, number 49 on your list is hydrogen carbonate. So hydrogen, remember, most of the time forms a +1 ion. It loses its electron and it's just a proton. Remember when I was showing you ammonium, when I diagram that out, it has a lone pair on the nitrogen, lone pair of electrons that hydrogen can stick to on ammonia, becoming ammonium. Well, the same kind of thing can happen on these oxygens. Remember, oxygen has 6 valence electrons. Okay, so it has 2 lone pairs, and the hydrogen can stick on oxygen as well. Okay, so here's the deal. That little sticky proton can come over here and stick. It brings with it its +1 charge. So 2 minus and a +1 gives you a 1 minus charge. This is hydrogen carbonate. And this is not going good. Okay, so hydrogen carbonate is the official name of this ion, but it's often called, I don't know what's better, the bicarbonate ion, which is really a misnomer. Bicarbonate. There aren't 2 carbons in here, okay? There's nothing that's 2 in this. It has to, I don't know why. It's just an old name. That's why hydrogen carbonate is clearer and cleaner. But you will hear of baking soda being called sodium bicarbonate. Sodium hydrogen carbonate is the formula for baking soda. Now, we still have a -1 charge. So if I put 2 hydrogens with the carbonate, it no longer has a charge, right? Another +1, and it's done. This is carbonic acid. So when there's no charge, it's a compound. Okay? It's all the ion, all the charges, all the electrons are taken care of. So when there's no charge, there's no symbol, this is a compound. And so you can put 2 hydrogens with the carbonate to make carbonic acid. Same kind of thing, I don't want to belabor this too much, but I just want to show you that once you know this 5 from the silly sentence, you can build a lot of other ions, okay? So let's look at the supper part of Nick the Camel ate a clam for supper. That's sulfate. Okay? It also has a -2 charge. It also can get a hydrogen stuck to it. That also takes away one of the electrons, if you will, and so this ends up with a -1 charge. Again, hydrogen sulfate is the name. And again, if we change and put another hydrogen on there, we cancel out the charge and we end up with sulfuric acid. So remember that 8s become ic acids. And then the last one, just really quick, is with phosphorus, and this one's even trickier. So, excuse me, I forgot to say, did I forget? Wow. This is with 1 hydrogen, that's the hydrogen sulfate ion. Okay. It's also called bisulfate, which again is dumb because there's not 2 sulfates. Bi implies 2. Okay, the last one is with phosphate. And if you do the little sentence, you get, Phoenix is 4 oxygens and a -3 charge. This time there's actually 2 more ions you can get. Okay, so you put 1 hydrogen on. It's hydrogen phosphate. You put a second hydrogen on. So we take away the charge one more time. We get a -1 charge. That's dihydrogen phosphate. And then finally, if we put 3 hydrogens on, that's phosphoric acid. Okay, this one has a -2, this one has a -1. Of course, PO4, show up a bit, 4 is a -3. So the phosphate. And all of these, as silly as it sounds, all of these can be phosphite, hydrogen, phosphite, dihydrogen, phosphite. Sorry for the lousy writing. And then, of course, last but not least, is phosphorus acid. So I know it probably is overwhelming, but all of these can be built from just knowing that Nick the Camel. All right, question. I heard somebody bloop in. Sorry to interrupt. After a couple of days, I feel that plus maybe. Thank you. I'm sorry, Marin. I hope everything goes well. All right. Any questions about the hydrogen things? I'm going to keep it simple on the compounds. And you do need to know hydroxide, of course, because it's a base. You do need to know how to name acids. You do need to know how to do the crisscross, whether it's binary or has a polyatomic. So let's look at the practice ones together, okay? So again, there's 20 questions in each. It's all multiple choice. It shouldn't take a terrible amount of time, but make sure you put your score in at least a couple of the ones you missed. And then if you want to do extra credit, why did this help? What did this help clarify for you? So binary compounds should be the easiest. You need to have a periodic table. And so if you came to campus in the fall, you should have gotten one when you came to my classroom. If you haven't yet, if there's any way you can print one, it'll make your life easier. I think I'll have one on the quiz, just like I'll have already on all the other ones, and you can switch tabs, I guess, or scroll up and down. But let's go through a couple of these, and then we'll look at the polys, and then we'll tune back into NASA. So these are binary compounds, and remember that second letter after the A is a lowercase l. Lots of times it looks like a capital I. So the guy that made this made sure that they look like L's, okay? And this is aluminum and chlorine. So the question is, what's the formula for aluminum chloride? Well, you need to find aluminum. It's a metal. It's in group 13 or 3A. It has 3 valence electrons, right? This is where that work a few weeks ago is going to pay off if you got those valence electron things figured out. Okay, so it's going to lose all 3, so it gets a +3 charge. Chlorine, of course, is a halogen, and it's going to have a -1 charge as an ion, as the chloride ion, right? So do your crisscross. The 3 from aluminum becomes a subscript on chlorine. The 1 from chlorine becomes a subscript on aluminum. You need 3 chloride ions with 1 aluminum. AlCl3 is the correct answer. Now, when you're trying to do this, everybody's questions come up in random order. They don't come up the same way, and I think even the answers come up in different orders. So, yeah, just FYI. So just follow along with me if you can. So Sr, hopefully you know, is strontium. It is an alkaline earth metal. It's group 2. It has 2 valence electrons. It loses both of them. What the heck is selenium? Oh my goodness. So selenium's over here in oxygen's family. That means it has a -2 charge when it's an ion. It has 6 valence electrons. It grabs 2 more. Strontium has 2 valence electrons, and it gets rid of them. 2 and 2 simplifies to 1 and 1. Okay, this is good. Copper with a parentheses 1 phosphide. That 1 tells you the charge. Remember, transition metals and tin and lead have variable charges. They have to have Roman numerals in their names. So copper has a +1 charge. It's giving away 1 electron. Phosphorus, phosphide, has 5 valence electrons. It wants 3 more to get its octet. It's going to have a -3 charge. So +1 and a -3 means we need 3 coppers and 1 phosphorus. This is not how many coppers there are. It's the charge on it. Let's do another one. Calcium with fluoride. Calcium's group 2. Has a +2 charge. Fluorine's a halogen, has a -1 charge. Crisscross it. I'm going to need 2 fluorines and 1 calcium to get to 0 charge. And last one, cesium. Cesium's in the alkali metals. Okay, you might remember that I said it's the most metallic element, loses its electron the easiest, has the lowest electronegativity, all that stuff. Cesium loses its 1 electron very easily, +1 charge. Oxygen always grabs 2 electrons. So this one only has 1 electron, so I'm going to need 2 cesiums with 1 oxygen to get to 0. Any questions on binary compounds? All good? Florida? Nobody's going to say anything. Okay, I'm going to move on to the polys. So again, this will still be handy, okay, to have a periodic table, because you need to know about the metals at least. All right, this is a great place to start. So iron with parentheses 2, Roman numeral 2. That means that it's lost 2 electrons. It has a +2 charge. Remember, iron is a transition metal. It can lose 2 or lose 3 electrons. Chlorate, remember chlorine, and it's 4 different permutations with oxygen. You go with 1 oxygen, 2 oxygens, 3 oxygens, 4 oxygens. Chlorate is ClO3, so I can get rid of the second option. That's not good. Again, the Roman numeral 2 tells you the charge, not that there are 2 ions. So that one's out. Okay, so which one is it? FeClO3, well, that's iron and that's chlorate. However, chlorate's a -1, so we need 2 of them. And it's a polyatomic ion, so you got to wrap it up in parentheses and put the subscript on the outside. This one, you'll probably remember because there's already a subscript. I remember hydroxide's the trickster that lots of people forget to put the subscript outside the parentheses if you need one. Name for the compound. So again, when you look at a formula, it looks so mysterious. It's not that bad. Look at the first capital letter. What element is that? K, hopefully all of you by now know, is potassium. And then C2H3O2. Hopefully you might remember from yesterday's work with acids and bases. That's acetate. Remember, potassium is an alkali metal. Its charge never changes. There's no need for Roman numerals. Don't add them in. So this is just called potassium acetate. This is a good little practice. There's a couple of these. Sodium with sulfur. So sometimes it's just binary. That's what the IDE ending tells you. And then sometimes there's oxygen, ite or ate. So sodium's Na. Sulfur is an element and it needs 2 electrons. Sodium has 1, so we're going to need 2 sodiums. So all these formulas are correct, but what this is checking is if you know the difference, if you're paying attention to the endings. Ide is with the element. 8 is 8 the most oxygens. So 4 is always going to be the 8. Okay, always 4 is always going to be the 8, and O2 is always going to be with a metal. Is always going to be the ite, but in this case, ite's less, so it's SO3. Here's another one. So again, sodium chloride, well, that better be pretty easy for you. That's table salt. Again, sodium with chlorine, the IDE ending says it's just the 2 elements. Ite and 8. Again, I can't remember that if it's a 2, it's always going to be the ite. And so 3 is more than 2 anyway, so hopefully you can figure those out. Okay, magnesium hydroxide. Again, magnesium is in group 2. It never changes its charge. There's absolutely no reason to write the Roman numeral 2. Does it have a +2 charge? Yes. But that's extra stuff we don't have to write because it only ever has a +2 charge. So OH you have to recognize as hydroxide. There's no such thing as dihydroxide, and there is a peroxide, but that's not this. So it's 2 hydroxides with the magnesium to get to 0 charge. but all we call it is magnesium hydroxide. And again, NO2, it's going to be nitrite. Okay? And even though zinc is a transition metal, it only ever has a +2 charge. Oops, I can spell, maybe. So it's just zinc nitrite. We write the least we have to. Questions on this? Okay, so you're going to go through and do those on your own, write your score, whatever you get at the end, and anything you had trouble with. And then we will review quickly before the quiz. Do go back and look at your acid-base naming rules from the worksheet. I'll try and get those done and sent. I graded them all. I don't know if I sent them back to you guys yet. Did I return the acid-base worksheet? Oh well, I'll double check.